Hello, you are watching the second lesson of the course Programming in C++. During this lesson you will know how a computer understands information and works with information. Also, what are the fundamental data types in C++ and how to use them. The goal of the lesson is to teach you how to make rational use of computer memory when writing programs. At the end of the lesson, you should be able to operate with fundamental data types in C++. Consider how a computer receives or understands and processes or works with information. A computer runs due electric current. A computer receives and understands the only impulses of electric current. The figure shows schematically the impulses of electric current. We interpret the sequence of current impulses as a sequence of zeros and ones. Converse is also true. The sequence of zeros and ones we can apply as a sequence of current impulses. What might be the smallest measure of information that receives a computer? It is clear that the smallest measure of information for a computer will be the presence or an absence of current impulse. That is, the smallest measure of information may contain 1 or 0. This smallest measure of information is called a bit. The sequence of 8 current impulses is information of 8 bits. 8 bits, a measure of information in a single byte. Measure of information in a single byte we assume as base measure of information in informatics. So, 8 bits is a byte. The amount of information in 1024 bits is called 1 kilobyte. 1024 kilobytes will be considered as 1 megabyte. 1024 megabytes are 1 gigabyte. Over a gigabyte should terabyte. With the help of operating system, you can find the size or amount of information of any file on your computer. The file can be interpreted as a sequence of ones and zeros that the computer's processor receives as a series of current impulses. We are not used to operate with a sequence of zeros and ones. Consider how a sequence of zeros and ones can be converted into familiar objects. How to associate the sequence of zeros and ones with numbers that we use in calculations. From these examples you see that this is possible, but we are interested in general scheme. Given a sequence of zeros and ones, leftmost digit of the sequence is multiplied by 2 in the power of 0. The next digit from the sequence is multiplied by 2 in the power of 1. Next digit in the sequence is multiplied by 2 in the power of 2, and so on. The result of the summation of products will be associated with the sequence of zeros and ones. Mathematicians say that the number written with the help of ones and zeros is the number represented in binary system. We use it to use the decimal number system. Therefore, this example demonstrates how to convert number from binary to decimal. A sequence of 8 zeros and ones is 1 byte of information. From other point of view, the sequence of 8 ones and zeros, that is a number. Define what is the maximum number that can contain a single byte of information. If a byte consists entirely of zeros, it will give us the smallest number, 0. If a byte consists entirely of ones, it will give us number 255. Therefore, 1 byte of information may include numbers from 0 up to 255. This is positive numbers. Sometimes we need to save the sign of a number. To save information about the sign of the number, we are using 1 bit of information. Then the remaining 7 bits allows us to save a number from 0 up to 127. As a result, you have to remember, a sequence of zeros and ones can be presented as a decimal number, and vice versa. To simplify the transformation, we use a calculator. Open the program Calculator, select the mode Programming. Type a decimal number, for example, 173. Convert it into a binary number system. Return the decimal presentation. Type decimal number 5,896. Convert it into a binary system. Verify that necessary amount of memory to store this number is 2 bytes, rather 13 bits. Type any number in a binary system. Convert it into the decimal system. These operations can be performed manually, but this is not lesson in algebra. Make a conclusion. I keep it quiet for a few seconds, and you try to comprehend what is written on this slide. By the way, can you estimate the amount of information in this slide? It is possible to find exact answer for this question, but this is a rhetorical question. Words should be weighed. The first part of the lesson is over. In the next part of the lesson, we will explore the fundamental data types in C++.